Moving on, we are moving on to lesson 6-2, and we are multiplying fractions. Our essential question today is, can you multiply algebraic fractions? So it sounds like we're going to get a little bit tougher than just numbers. The multiplication rule for fractions tells me that a over b times c over d can combine. And just a reminder of the rule of exponents for a power of a quotient, a over b to the m, remember that m is going to not just go to the a, but also go to the b. So that will be a to the m over b to the m. Now, let's go ahead and get out our calculators. Let's have some fun and just throw this in our calculator. A reminder to get to a fraction on your TI-84, which is what we use, is you are going to hit alpha, which is the green button. And then the top left button, I don't think it says Y1, I think it says Y equals. And then you're going to hit number 1, where it throws a numerator over a denominator. So you're going to have to do this 1, 2, 3 times to put your fractions in. And I'm just going to let you practice that. So go ahead and push pause and give that a shot and practice it, and then we'll get back to it. All right, let's go ahead and go over old school multiplication with fractions. Remember, we can reduce. 5 goes into 20 4 times. 7 goes into 14 2 times. 3 goes into 15 5 times. So my answer on top is 8 because I'm just multiplying straight across, and my answer on the bottom is 5. So my answer is 8 over 5. So when you use your calculator, did you get that? Great. Have fun with that calculator, because example 2, you are unable to use a calculator. So let's talk. I have 12y over z cubed times z over 15. Now, some people like to combine everything. I like to cross reduce. You can do it either way. You can write this all together if you want to write this as 12yz over 15z cubed, and then you could say top or bottom. We'll do both ways, so let's go ahead. I'll do the first way in blue. 12 and 15 can reduce. Both of them reduce by 3, by 3. And we get 4 over 5. The z's will end up on the bottom because there's 1 on top and 3 on the bottom, so we're going to have 2 left over on the bottom. So when I combine everything here, it looks like on top I have 4y. Don't forget this y. That's probably one of the biggest problems with this. I end up with 4y. And on the bottom I have 5z squared. Now, if you like to combine, that's fine. Combine. We're going to get the exact same thing. 3 goes into both, so I get 4 and 5. And z's go on the bottom as z squared. And so I get 4y over 5z squared. So it doesn't matter which way you choose. We just want to make sure we get it right. All right, let's get to more fun today. Yesterday's lesson, we had to reduce. We had to factor. So guess what we're going to have to do today? We're going to have to factor. So notice right here, I can take out an a, and I have a squared minus 25. And I know you're thinking, wait, that continues on. It does. So when we rewrite it, I'll rewrite it over here. We're going to continue to rewrite it. But on the top right, notice I have a squared plus 10a plus 25. And you're probably thinking, oh, this can be a plus 5 quantity squared. Because once again, you guys are my factoring rock stars. Now, I'm going to take the time to rewrite this. I'm going to rewrite this fraction right here on the left. So I have a minus 5 divided by a times, well, I know that a squared minus 25 is a plus 5, a minus 5. I'm running out of room. And remember that was multiplied by, and I'm going to take the time to write it out twice because I want to see those binomials in case they can cancel. So here's what we end up getting. A minus 5 over a times a plus 5a minus 5 times a plus 5a plus 5. Now remember the rule, I like to keep things together. So I'm going to put this little guy together because these binomials can only cancel if they're being multiplied. So notice this a minus 5 and this a minus 5 can cancel. Notice this a plus 5 and this a plus 5 can cancel. So what I have left is an a plus 5 over a. Now, a lot of you are going to say, wait, can these cancel? They cannot cancel because of the plus and minus. So that's why I always keep these little couples coupleted together because I think it's so important to see that they can only cancel as a binomial couple. All right, let's look at this one, example 4. I don't think there's anything canceling here, but how many times is 2 over y being multiplied? 3 times. You can write that all out. 2 over y, 2 over y, 2 over y, and we get 8 over y cubed. Do we have to write that all out? No. We can say that this is 2 to the 3rd power and y to the 3rd power. Well, I know 2 to the 3rd power is 8, and y to the 3rd power is y to the 3rd power. Now they start us out for there because they want us to continue like example 5. So it looks like we have a few steps in example 5 we will do together. Remember that one time I made you memorize all your perfect squares and cubes? It's because of this. What is 4 cubed? 64. Well, y cubed is obviously y cubed. And don't forget this guy. He's going to go to the 3rd power as well. Z to the 3rd power. All of this I'm just going to rewrite because there's nothing I can do here. And from here, I like to reduce. If you want to smush it all together and then reduce, that's fine. I know that 8 goes into 64 8 times. I know y goes into y cubed, y squared, and z goes into z cubed, z squared. Don't forget this random 3. Sometimes we forget that little guy. So 8 times y squared times 3 is 24 y squared. And on the bottom, it looks like I just have a z squared, and there's nothing else that can reduce there. Great job. All right, I have more practice problems. Let's just give you these 6 right here. So if you guys could push pause and go over these 6, the answers are in the book. Great job. I'm so proud of you. You guys are doing awesome.